There are many gaming test videos done and uploaded on this channel. We've tested devices ranging from budget entry level to the highest end that is available in the market right now. Not only phones, mind you, but also tablets and sometimes laptop as well. One thing that I always talk about in those videos is thermal throttling and the thermal limit. I have never explained about it before, so this video is where we are gonna talk about it in detail, or at least I try to include as many details as I can. So this is gonna be a very long video, so get some snacks and get some drinks as well. And before we begin, please do like and subscribe because I've spent many hours and rewriting this script countless times before filming and editing this video. We have no sponsors, so your like and subscribe, it really do help us out a lot. So let's get started with the most obvious question first. What is thermal throttling? Well, to put it simply, it's a safety measure to ensure your device doesn't overheat and damage itself, but still operational, albeit at a lower clock speed. That is what happens in this part of the graph. We'll talk about this app later in the video, so just if you want, then you can skip it to the whatever section that you want in this video because everything is timestamped. I will have to give you guys a quick history lesson first. Our devices technically doesn't overheat, so this kind of message is practically just telling you that your device is now thermal throttling so hard to the point that it doesn't allow you to do anything else until the device is cool enough. You see, back in my days, yes, I am that old, when our PCs overheat, they literally can permanently damage itself with the transistor going beyond the junction temperature. Then the engineers put some countermeasure in place and it automatically cuts off power when it reaches a certain temperature threshold. Think of it like a thermostat in your oven. Practically, it is a thermostat in an oven kind of principle. So if it's too hot, then it just cuts power entirely. That is step one. Step 2 is by introducing something called dynamic frequency scaling, or DFS for short, and it is a simple idea that allows the processor to downclock itself. It is very important because processors used to be operating at just a single frequency only. By allowing the processor to downclock itself, that means the power consumption can be decreased, and that also means the introduction of thermal throttling. By following the general formula of power consumed by a processor as shown on the screen here, we can decrease the voltage to decrease the frequency, and hence the power consumption can be dropped by several magnitudes. Less power consumption means less power loss, and that is how we can use this technique to save power when it is idling and thermal throttle when it is needed. Actually, come to think of it, any devices with the power saving or light performance mode is technically just deliberately throttling the performance. I really never thought about this before. Now, I'm sure you want to ask, what is the thermal limit? Simply put, that is the value that dictates what temperature should the device start thermal throttling. For example, in Genshin Impact for the Galaxy S24 Ultra and the Galaxy S24 Plus, it has a thermal limit of around 46 degrees Celsius. But the ROG Phone 5 with the Snapdragon 888 has a thermal limit of 60 degrees Celsius. Yes, different phones with different chipsets have a different thermal limit. Tablets rarely thermal throttle because it is rather difficult to reach that thermal limit since the entire tablet is a giant heatsink. For mobile devices like our phones, the most heat-sensitive component, which is the battery, can operate all the way up to 75 degrees Celsius. However, the thermal limit is set much lower to protect our hands. Also, we don't just touch the device and say, "Oh, it feels hot," because if the temperature difference isn't that huge, then we can only feel a slight warmth. But if the temperature difference is very huge, then we will definitely say that it is hot, even though, let's just say, the environment is like 20 degrees Celsius, but the device that we are holding is at 50 degrees Celsius. With a temperature delta of 30 degrees Celsius, we will definitely say that it is hot. But for someone who is living in a hot climate weather, like what I'm doing right now, then I wouldn't say that is particularly hot. But now I'm gonna go ahead of myself a little bit and talk about software. A firmware update could technically, quote-unquote, change the thermal limit, but I don't have any supporting evidence for it. And there's just some anecdotal evidence. There is also another thing that I found out. Some devices have two thermal limits. The first example is Samsung devices. The alternate game performance management mode technically just lets us operate the device in a higher thermal limit so we can get more performance until it thermal throttles, that is. Another example I think is a big problem is like the recent Xiaomi 14 and the Xiaomi 14 Ultra that we've tested. While we are playing games, it obviously thermal throttled at around 47 degrees Celsius, but somehow when we run 3D Mark Wildlife stress tests, it displays this message every single time. After trying multiple times, I got it to complete once, and it actually reported 54 degrees Celsius. You see the issue here? Speculation, this could be a big problem to cheat in benchmarks somewhat. You see, this is done to increase the thermal limit for benchmark apps only. Most benchmark apps require a short burst of performance and the benchmark will be complete before the device starts thermal throttling. That is why I don't really use a benchmark app. The most that I will use is the 3D Mark stress test. It runs the test 20 loops back to back. Usually, I will just do a straight up gaming test that gives us a more tangible result of what we are going to experience if we are playing the games on that particular device. If it performs well in the game, then great. I don't really care what score it gives out in benchmarks. So how do we get rid of the heat and minimize thermal throttling? That leads us to the next part of this video, thermal dissipation, also known as cooling system. Most of our phones now use a passive cooling system, and since it doesn't have a fan, it's not really effective on high-end devices. If you want a phone to perform its best, then try not to use a phone case or a screen protector since those will act like layers of insulation and trap heat within the phone. That is why we will remove phone cases when we do our gaming tests. And for the screen protector, if it comes with one, then I can't really do anything with it, so I'll just leave it there. The physical design of the device and material also plays a big role in terms of thermal dissipation. You see, Android phone comes in many different shapes and sizes. We have the ROG Phone series that move the chipset to the center of the phone, and their aeroactive cooler sits directly above the chipset. However, most Android phone will have its chipset placed somewhere near the camera bump. Since most phone brands insist on having a big-ass circular camera bump, that essentially covers up the chipset as well. The worst offender here is the Xiaomi 14 Ultra, as the camera bump is so big that it literally acts like a heat trap. The PU leather material might also act like a heat trap as well, and that is why the gaming performance on the Xiaomi 14 Ultra is the worst out of all Snapdragon 8 Gen 3 phones that I have tested. Technically, phones that are made out of a solid block of metal like the HTC One M8 will perform the best in terms of thermal performance since the entire phone is a giant heatsink. But NFC and wireless charging will not work. iPhones and iPads, on the other hand, has the chipset placed around the side of the device along the frame. That is why they will feel hot at one side of the device. The thermal interface between materials also play a big role, but that will be a topic for another day. You might ask, how about adding an external cooler onto the phone, like the Black Shark Fun Cooler 3 Pro? It's a Peltier cooler with a fan, so it will prevent the phone from thermal throttling if we just put it at the back of the phone, right? Actually, yes, we tested this with the Galaxy S24 Ultra and the S24 Plus in our previous videos that you can watch at the top right corner there. And yes, it works as expected. However, these coolers are retrofitted on the phone and expect them to make proper contact with the back of the phone. Just imagine that if the back of the phone has a huge circular camera bump or a curved back, then this cooler is not gonna be in ideal condition. There are also phones that are made to work better with a cooler. For example, the ROG Phone 8 has a piece of rapid cooling conductor on the chipset. Essentially, it's a heatsink, so it bypasses all of the layers and conducts heat directly to the back of the phone, and if you have a Aeroactive Cooler X there, then it will just directly make contact with it and cool the chipset in a more direct way. This is rather reminiscent of those big tower coolers in your desktop PCs. Okay, now onto the chipset. Obviously, the chipset itself plays a big role as it is the main contributor of heat. Basically, the most modern flagship smartphones, they'll heat up. Like in the case of the Snapdragon 8 Gen 3, when we play games like Genshin Impact, the 8 Gen 3 will heat up a lot more. Thanks to GeekerOne, they have logged this graph here. We can see that the maximum wattage on the 8 Gen 2 is much lower, but the 8 Gen 3 is 4 watts higher. That will ultimately result in unnecessary heating with minimal performance gains. That unnecessary heating issue we also discovered in our gaming test as well. It would be much better for the 8 Gen 3 to retain the same wattage limit as the 8 Gen 2 so it wouldn't thermal throttle. That would be much better, right? We get more consistent performance but not that high of a performance. I would actually prefer that more than just thermal throttling like out of nowhere. And actually the 8 Gen 3's excessive heating issue can cause the phone to thermal throttle to the point that the performance is rather comparable to the 8 Gen 2. For sustained long-term gaming performance in a warm climate country, the 8 Gen 2 is actually very competitive even in 2024. We can get a concrete result here by just looking at the 3D Mark stress test benchmarks. But two of the phones with the same chipset can also perform differently, like the S24 Ultra and the Xiaomi 14 Ultra. Different companies, different phones, same chipset, different performance. That is why we will still do our gaming tests for as many phones as possible even though they are still using the same chipset. Now, there is a reason why people never complain about overheating for chipsets like the Snapdragon 685. That's because those kinds of entry-level chipsets just doesn't heat up. Yes, the performance is just not that good, but if we run the 3D Mark stress test benchmark on those devices, we can see the stability is magnificent. The chipset architecture and fabrication also plays a big role, but we can further break it down to two more factors that affects the chipset's performance and efficiency. First is the fabrication process. That is where companies like TSMC, Samsung and Global Foundries use their expertise to manufacture those chips. I'm skipping a bunch of factors here like the lithography process, binning, yield rate, all of those stuff because that's gonna be lengthy. But all of those plays a major role in the final quality of the chip itself. Second factor is the processor's architecture, as in how the chip is designed. Some chips are designed in such a manner that it is just inefficient and it won't be magically improved if we use the latest and greatest TSMC fabrication technology, just like the Snapdragon 810 for example. That chipset had a reputation of just heating up for no reason. And I'm not an expert in this, but I think we can closely relate back to the formula that was presented earlier, and that C in the formula here represents capacitance. If the chip's design has a high internal capacitance, then it will consume a lot more power and potentially has a lot of power loss as well. And now the software. Yes, the software plays a big role as well. Have you ever experienced a new firmware update on your phone that seemingly results in less battery life? Yes, that's because that particular update is not well made. Yeah, like the iPhone 15's overheating issue when it was first launched. A bad update can cause a processor to do unnecessary things and that results in a decrease of battery life and performance that we're gonna get. Even excessive background apps or rogue apps in our phones can take up resources and cause the device to heat up as well. By minimizing overheat, we can increase efficiency and that means less heat. And let's not forget about the governor that our device is using. If you've been playing with custom ROMs, then you will have come across this term before. A governor dictates how the processor should respond to a workload when it is presented. For example, you can make it to downclock as much as possible to conserve your battery life or make the processor to be constantly at a high frequency to ensure smoothness. Of course, this takes a lot of fine-tuning if we want to balance between performance and battery life. Both the Snapdragon 8 Gen 3 phones that I have here is using the Vault governor, whereby the S24 Plus with the Exynos 2400 is using Energy Aware. Some firmware updates also come with new driver updates as well. These driver updates will bring forth some optimizations and that will also affect the performance that we're gonna get and could potentially cut down on some overheat. And one more thing that I want to highlight here is RAM speed. Most people will just say that having more RAM in your device is better, but that's only half the story. After about 8 gigs of RAM, the more RAM that you have doesn't actually help you in terms of performance, but your RAM speed does. It heavily affects your loading speed. Having a faster RAM means that the CPU doesn't need to wait for the RAM to load stuff, hence you can actually cut off some overhead as well. By the way, please turn off the virtual RAM feature. It is detrimental for your device and it creates unnecessary wear on your storage chip. We've talked about this in our previous video, so watch it at the top right corner there for more information. Okay, another thing that affects thermal throttling is your game settings. Obviously, higher graphics settings means that it will affect your performance, and so does the render resolution. Now, I think many of our viewers don't really understand what render resolution is, so let me give you a quick explanation here. This monitor behind me is at 5120 by 2160 pixels in resolution. However, my computer that is connected to this monitor can run at a much lower resolution, for example 2160 by 1080. It looks very ugly, but I do get much better frame rates out of it. Same goes to phones as well. Your phone may be 1440p, 1080p, but those games will probably be rendered at 720p, 540p, or 1080p. Sadly, until today, only Samsung devices lets us see the render resolution of a game, and different phones can have different render resolutions. I also know that some phones are playing around with the render resolution to give it a bit of an artificial boost to the frame rates, like the ROG Phone 8. It can maintain Genshin Impact at the highest graphical quality, but the render resolution is really low. We can clearly see it in this circle shape right here. Optimization of a game for the particular chipset is also important. We've talked about how drivers can be optimized for that particular game, but the game will also need to be optimized for the hardware as well. For example, COD Warzone had some weird issue with Exynos devices, whereby it will say connecting and then the phone will just hang. That issue has been fixed right now. By the way, Genshin Impact is going to update their game engine and improve the graphical quality even more. That means higher performance requirement, and phones with the Apple A12 or the Snapdragon 865 or older will have the graphical quality downgraded even more. That will mean that we will probably need to redo our gaming tests again when the new region is unlocked. So do subscribe if you don't want to miss out on that, because we will definitely do another roundup like what we did previously. Okay, the biggest question that many of you will ask me is, can we avoid thermal throttling? I would say in some ways, yes. The options that are within our control is to change the graphical quality and limit the frame rate, but that is the exact opposite reason why we are buying high-end devices. Having the device to operate in a colder environment and having a Peltier cooler is definitely gonna help to mitigate thermal throttling, but that is a tall order for those who are staying in a warm climate region like us in Malaysia. Other methods to mitigate thermal throttling is totally out of our control, unfortunately. I think we can utilize some technologies like graphic upscaling. Having something like NVIDIA DLSS or AMD FSR in our phones means that all of a sudden we can potentially have the same graphical quality but at a more power efficient level. Frame generation technologies will also improve the frame rate, which I think is very beneficial for phones and tablets. However, when the hardware is available on our devices, we will have to wait for the game developers to support these features. That will definitely take a much longer time. Yeah. More and more bespoke cooling solutions are also in the works. We have seen the AirJet from Throttling, which uses MEMS, micro-electromechanical systems, to cool down processors. It's an entirely new form factor of cooling devices, and the reason why I bring up the Throttling AirJet in particular is because of its size. Imagine we can just slap it onto our phone like a bandage and all of a sudden the temperature decreases. That's good, right? Even better if the phone companies start to integrate these coolers in the phone. And we'll see how things go in the future. Another method that we can do to minimize thermal throttling by a little is to use a feature called battery bypass. It will minimize the battery's heat output by just a little bit, but this feature is not magic. Your device will still thermal throttle eventually, but with the battery out of the equation, your device will still eventually thermal throttle, but your battery though is not stressed. That means your battery will have a longer lifespan. That's good if you want to use your device for as long as possible or even resell it with a higher battery health percentage. I also do not use these kind of apps to do any sort of testing. I think it's quite stupid, honestly, because it only stresses the CPU to its maximum, but when we're gaming, the GPU also plays a role. And yeah, this kind of app is just not representative of how we actually use our phones. That is why I just did gaming tests a few years ago and I stuck with that idea until today. If you're using the same settings that I did in those videos, then you're gonna get exactly those frame rates. So it's pretty straightforward, right? That is all that we have to share with you today. Thermal throttling is a rather inevitable thing, but there are some things that we can do to mitigate it. For high-end devices in particular, I really hope engineers can start incorporating some sort of fancy technologies to mitigate thermal throttling. And this video really took me a very long time to do from start to finish. I've actually been filming for like 45 minutes. But I'm pretty sure I'm still missing out some points. So do let me know down in the comment section below. I'll answer them whenever I can. And please do remember to like and subscribe. And then share this video with your friends because that will really help us out a lot. Also, do let me know what other topics you want us to talk about in the future. I'm constantly reading the comment section, so let me know all of your thoughts. Yeah, this video is long enough and I'll see you in the next one. Hope you learned something.